In the 21st century's accelerating race for technological dominance, a new and unexpected power has surged ahead with staggering speed, reshaping global expectations and sending tremors through the halls of American industry, intelligence, and innovation. This is the story of a nation that transformed itself from the world's factory into an engine of futuristic breakthroughs. China, a country now unveiling humanoid robots that mimic human motion, smart cities that think for themselves, and electric supercars that defy the limits of engineering. Our journey begins in Shenzhen, often called the Silicon Valley of the East, a city that rose from fishing villages less than 50 years ago and now stands as a glowing testament to China's rapid technological rebirth. Inside its ultra-modern labs, humanoid robots are being sculpted with levels of mobility, dexterity, and intelligence once imagined only in Hollywood films. American strategists watch closely as Chinese robotics companies reveal machines capable of precision movements, facial recognition, emotional response mapping, and autonomous learning abilities that push the frontier of artificial intelligence far beyond industrial automation. What truly alarms U.S. analysts is not the existence of these robots, but the speed with which China develops them. Teams of young engineers, many under 30, work around the clock with national funding, military support, and corporate backing. Their humanoid prototypes run, jump, carry objects, perform surgical-level tasks, and work harmoniously with human teams in factories, an integrated dream of efficiency that American facilities have yet to match. In multiple sectors, China's humanoid robots now demonstrate agility levels reminiscent of Boston Dynamics, yet priced far lower, making them globally competitive and highly scalable. Experts warn that the combination of AI robotics and China's manufacturing ecosystem could ignite a new industrial revolution, one where physical labor becomes digitized, predictable, and infinitely expandable. But the robotics revolution is only one part of China's accelerating ascent. Across the country, entire smart cities are emerging from the ground like scenes from a futuristic novel. Complex urban organisms wired with sensors, AI networks, surveillance systems, and fully automated infrastructure. In cities like Shenzhen, Hangzhou, and Xiong'an, traffic flows without human supervision, power grids adjust in real time to consumption patterns, water systems monitor themselves, and public transportation operates with clockwork precision. The United States, which once pioneered high-tech infrastructure, now faces a startling reality. China is building urban environments designed from scratch around artificial intelligence. Take Hangzhou's City Brain, an AI supersystem developed by Alibaba that monitors thousands of intersections, predicts accidents before they happen, optimizes ambulance routes, and reduces emergency response times by more than 50%. American urban planners, constrained by aging infrastructure, political gridlock, and budget challenges, find themselves years, perhaps decades behind such integration. Meanwhile, Xiong'an, branded as the city of the future, employs autonomous vehicles as standard transportation, AI-regulated utilities, facial recognition payments, and energy efficiency strategies unmatched anywhere else on Earth. American observers worry that these smart cities offer China more than convenience. They create datasets of unimaginable scale, training next-generation AI models that the West cannot easily replicate. But China's technological evolution doesn't end with smart cities or robotics. It extends into a domain that symbolizes national pride, industrial excellence, and global influence: supercars, particularly cutting-edge electric vehicles. A decade ago, China was dismissed as a producer of inexpensive budget cars, functional but far from elite. Today, companies like BID, NIO, XPeng, and Hi-Fi are launching electric supercars capable of rivaling, and in some cases outperforming, American and European competitors. Equipped with advanced solid-state batteries, aerodynamic designs, AI-assisted driving systems, and speeds that shock Western critics, these machines reflect not just engineering prowess, but a deep cultural shift. China no longer seeks to imitate, it aims to lead. American manufacturers are stunned as Chinese EVs achieve ranges exceeding 1,000 kilometers, charging times under 10 minutes, and acceleration rates previously achievable only by luxury brands like Porsche or Tesla. Worldwide, buyers notice that Chinese EVs are not only powerful, they're affordable, a combination that could reshape global automotive markets. Tesla's dominance is no longer guaranteed, and Detroit's long-standing automotive legacy faces its most formidable challenger yet. Viewed from Washington, D.C., these developments raise pressing questions. How did China leap ahead so quickly? And what does this mean for America's centuries-old role as a global leader in innovation? The answers lie deep beneath the surface, hidden in China's strategy of long-term planning, rapid prototyping, industrial discipline, and aggressive investment in emerging technologies. While American corporations often prioritize quarterly profits, Chinese enterprises and the government backing them focus on decades-long technological roadmaps. This philosophy has allowed China to compress centuries of development into a few decades, achieving in one generation what took the West 100 years. Inside America's intelligence community, a quiet alarm bell rings. Analysts warn that China's progress in robotics could transform global supply chains, reduce dependency on foreign labor, and give Beijing unprecedented leverage. Military strategists worry that humanoid robots, if adapted for defense purposes, could change the nature of warfare, offering China logistics efficiency, endurance, and battlefield automation that the US has yet to match. Meanwhile, energy experts caution that China's EV dominance could give it a commanding role in the future of global battery supply, a resource as critical as oil once was. Yet perhaps the most unsettling development is China's ability to integrate these technologies, robots inside smart cities feeding AI ecosystems powering vehicle networks, and vehicle networks generating more data to refine robotics. It is an interconnected web of innovation with a single objective: technological sovereignty. For America, the challenge is not simply catching up, it is understanding that the race itself has transformed. What was once a contest of ideas is now a test of speed, scale, and geopolitical willpower. And as China unveils humanoid robots that walk like humans, cities that think like machines, and supercars that feel ripped from the year 2035, the world watches in awe, shock, admiration, and perhaps fear. Because this is no longer a story of competition, it is a global turning point, one that will determine who controls the technologies that shape the future of civilization. As America attempts to understand the magnitude of China's astonishing technological acceleration, a deeper narrative begins to unfold, one built not only on innovation, but on a vastly different national philosophy regarding progress, competition, and the very purpose of technology itself. In the United States, innovation thrives in private companies, independent research labs, and entrepreneurial risk-taking. But in China, the ecosystem is engineered from the top down, with government policy, corporate ambition, and military strategy woven together into a tightly synchronized machine. This fusion, known within Chinese political circles as the National Technology Integration Model, has created a momentum the world struggles to comprehend. Inside China's robotics complexes, the atmosphere is almost militaristic in its precision. Teams operate in layered cycles: design, test, rebuild, relaunch at lightning speed. Unlike many Western firms constrained by cost, regulation, or public hesitation, Chinese robotics companies receive massive funding, expansive datasets, and a government willing to take bold risks. Their humanoid robots, which first resembled stiff metal frames a decade ago, now walk fluidly, execute fine motor tasks, converse with natural language precision, and operate autonomously in simulated emergency scenarios. Some American specialists have privately admitted that China has cut the robotics development timeline by at least a decade. But the consequences extend far beyond manufacturing. In hospitals across Beijing and Chengdu, humanoid robots assist nurses, monitor patients, and manage supplies with error rates near zero. In disaster-prone regions, robots navigate rubble, search for survivors, and map hazardous areas more efficiently than human teams. The American emergency services sector, despite being technologically capable, lacks the sheer integration and scalability to deploy such solutions nationwide. China's model-dense sensors, reachable data, state-run coordination allows for real-time deployment at a scale that seems almost impossible in the United States. Meanwhile, China's smart cities continue evolving, each one acting as a living laboratory for experiments few democracies would ever attempt. In Shanghai's Pudong district, autonomous drone fleets monitor air pollution from the sky, sending live data to AI servers that adjust traffic patterns and industrial output on the fly. In Guangzhou, smart waste systems use facial recognition to track recycling habits, rewarding citizens with digital credits for proper disposal. While Western critics often raise concerns about privacy and surveillance, Chinese officials view these systems as essential for managing megacities housing tens of millions. American urban planners study these developments with a mixture of curiosity and concern. The sheer data volume produced by Chinese smart cities' vehicle movements, energy usage, pedestrian patterns, pollution fluctuations feeds algorithms that grow smarter each week. Where the United States battles with aging roads, outdated grids, and political debates, China constructs entire cities preloaded with AI, allowing technology to guide every operational layer. Silicon Valley innovators privately concede that even if America builds smart cities of its own, it may take decades to reach the level of deep structural integration found in China's newest urban projects. But perhaps the most surprising aspect of China's rise comes from its automotive revolution. For decades, American and European automotive giants dominated engineering, luxury, and performance. China's early cars, often criticized for their quality, were dismissed as mere imitators. Not anymore. Today, Chinese EV manufacturers lead global sales, with BYD surpassing Tesla's quarterly numbers and NIO introducing advanced battery swapping stations that replace a car's entire power unit in under 3 minutes, a feat that American charging infrastructure cannot match. But the true shock comes from China's supercar division. Take the Hi-Fi Hyper SSR, an electric supercar with acceleration speeds that rival the best from Italy and Germany. Its futuristic interior, AI voice controls, and aerodynamic design redefine what an electric hypercar can be. Then there's Speng's flying vehicle prototypes, cars that transform into vertical lift drones capable of short-range aerial travel. These once impossible machines are no longer concept art, they're real, tested, and already entering limited-run production. American engineers marvel at the speed of this transformation. How did China, once mocked for copying designs, leapfrog into the future? Analysts point to 3 major factors. 1. State-backed industrial strategy. China's government identifies high-tech fields AI, EVs, robotics, aerospace, and pours billions into them without hesitation. Companies align with national objectives, creating a unified technological front. 2. Massive consumer base. With more than 1 billion citizens and an exploding middle class, China's domestic demand allows companies to test new tech at scale. The US, by comparison, cannot match the same experimental volume. 3. Supply chain mastery. From lithium processing to semiconductor assembly, China controls critical components needed for robotic systems, smart city sensors, and EV batteries. Even American companies depend on Chinese parts. These advantages converge to create a technological wave that now challenges America's global influence. U.S. military leaders worry that China's advancements in robotics and AI could spill into defense applications. In classified briefings, experts warn that autonomous machines combined with AI surveillance could drastically reshape warfare, favoring those who control the data, the networks, and the automated logistics. American automakers, meanwhile, face an existential threat. Detroit's legacy industries struggle to adapt to the pace of innovation seen in Shenzhen and Shanghai. The U.S. remains a leader in combustion engine engineering, but the future belongs to electric power, and China owns the supply chains, the patents, and the market share. Tesla, despite its dominance, operates factories in China and relies heavily on materials sourced from China's industrial belt. Inside Washington, policymakers debate how to respond. Should America rebuild its manufacturing base? Should it strengthen alliances with India, Japan, and Europe to counterbalance China's rise? Should it invest billions in AI infrastructure to challenge China's smart cities? The answers remain uncertain, but one truth becomes clear: the technological rivalry between the two nations is no longer theoretical. It is alive, escalating, and deeply embedded in every sector of modern life. Back in China, the momentum continues. New humanoid robot prototypes appear monthly. Cities integrate digital systems that would overwhelm Western privacy norms. EV brands unveil faster motors, lighter bodies, As the technological momentum of China intensifies, America finds itself confronting a reality that few experts predicted even 20 years ago: a strategic competitor capable of reshaping the global technological order at breathtaking speed. With every new breakthrough, humanoid robots that replicate human behavior, cities that function on AI autopilot, and electric supercars that outperform Western engineering, China's transformation accelerates. Yet behind this transformation lies a deeper, more unsettling truth: China's rise is not accidental. It is engineered, calculated, intentional, and decades in the making. To understand how China stunned the world, historians turn back to the late 1990s and early 2000s. While America celebrated its status as the world's sole superpower, Chinese policymakers quietly drafted long-term national strategies: mastery of supply chains, domination of advanced manufacturing, control over key minerals, and most crucially leadership in emerging technologies. Where the United States relied on private companies to innovate organically, China used a hybrid approach: centralized planning fused with corporate dynamism, a structure that proved surprisingly effective. This system enabled China to funnel enormous resources into research, education, and industrial capacity, creating a technological ecosystem that expanded exponentially. Today, the results are undeniable. Inside China's newest robotics labs, constructed almost overnight, engineers test humanoid machines capable of running marathons, lifting heavy loads, and performing assembly tasks with surgical precision. Some prototypes even integrate synthetic skin with advanced tactile sensors, giving robots the ability to feel pressure, temperature, and texture. This breakthrough, once thought decades away, brings China closer to human-level robotics, an achievement that alarms American scientists observing the advancements through academic papers, leaked footage, and international tech expos. As China's humanoid robots continue to evolve, American industries brace for disruption. Manufacturing, which once relied heavily on inexpensive human labor in Asia, may soon rely on Chinese-designed robot labor, reducing costs further and deepening China's industrial dominance. The ripple effects could be enormous: global supply chains shifting toward fully automated facilities, Western factories struggling to compete, and entire industries facing reinvention or collapse. For the United States, this is more than an economic challenge, it is a strategic one. While robotics reshape manufacturing, China's smart cities reshape urban life itself. Step into Xiong'an New Area, the flagship smart city often described as China's brainchild of the future. Here, AI manages everything: water flow, electricity distribution, rail schedules, drone deliveries, autonomous buses, and even emergency response protocols. Day and night, billions of sensors feed information into central AI hubs that continually optimize the city's functions. Streetlights brighten as pedestrians approach. Waste bins summon autonomous trucks when full. Entire avenues shut down and reroute traffic within seconds to clear paths for ambulances. To many visitors, the experience feels almost unreal, like stepping into the set of a futuristic film. American observers, mayors, engineers, researchers visit these cities with fascination. They walk through spotless streets, watch AI-controlled intersections empty themselves like magic, and witness vehicles glide without human drivers. But their admiration is accompanied by an uncomfortable awareness: replicating such integration in the United States is nearly impossible in the short term. America's cities are old, heavily populated, politically decentralized, and constrained by regulations. China's advantage is structural, baked into its centralized planning and rapid execution. Yet as smart cities grow, China's influence stretches beyond its borders. Through its Belt and Road Initiative, China exports surveillance tech, smart city infrastructure, and AI systems to dozens of countries: Africa, Southeast Asia, the Middle East, Eastern Europe. These nations, eager for modernization, embrace China's technology and, in the process, become part of China's global digital ecosystem. For the first time since World War II, the U.S. is witnessing a world where technological leadership is shifting toward an Eastern power. The implications are profound. Then comes the automotive revolution, where China makes perhaps its most surprising leap. The rise of Chinese electric supercars signals a seismic change in global automotive identity. Where American muscle cars once defined power, and European brands symbolized luxury, China's electric supercars now embody the future: silent engines, instant acceleration, AI-controlled suspension, self-driving platforms, and batteries more advanced than anything produced in Detroit or Stuttgart. Chinese EV manufacturers don't merely follow trends, they create them. Companies like NIO introduce battery swap stations across entire regions, enabling drivers to replace a drained battery with a fresh one in under 5 minutes. Speng's flying vehicles transition between road driving and vertical liftoff, demonstrating capabilities that seem straight out of a futuristic battlefield or a sci-fi blockbuster. Even BYD, once dismissed as a budget brand, now produces EVs with range, performance, and build quality that rival Western icons. In America, automakers scramble to respond. Legacy companies face an uphill battle as they attempt to modernize factories, secure battery supplies, and adopt AI systems, all while balancing investor expectations and labor costs. Tesla remains competitive, but even Elon Musk acknowledges China's EV sector as the strongest in the world. Some American car executives privately fear that China's automotive dominance is inevitable, given its supply chain control and unstoppable pace of innovation. But what truly elevates China's rise is the interconnectedness of its advancements. Humanoid robots manufactured inside China's factories help build the batteries that power China's EVs, which connect to China's smart cities, which generate data that trains China's AI systems, which improve the robots in a feedback loop of exponential progress. The United States, though technologically advanced, lacks such unity. Silicon Valley, Detroit, and Washington operate as separate spheres, often in conflict, rarely in sync. This interconnected architecture gives China a decisive advantage, a kind of technological gravity pulling the future toward its center. Inside American intelligence agencies, analysts express increasing concern. Confidential reports warn that China's AI and robotics industries could eventually outpace the West to an irreversible degree. Defense analysts fear that autonomous systems, drones, robots, surveillance networks could shift the global balance of military power. In closed-door hearings, national security officials urge lawmakers to act swiftly, rebuild supply chains, invest in manufacturing, expand AI research, and counter China's expanding digital reach. Yet political divisions, corporate pressures, and public skepticism slow America's response. Meanwhile, China moves forward without hesitation. Even now, new robotics labs are under construction. New smart city districts are being planned. New EV prototypes are undergoing wind tunnel tests. The pace is relentless, almost overwhelming. As historians examine this moment, they see a familiar pattern: the emergence of a new global superpower defined not by military conquest, but by technological supremacy. Just as Britain dominated the industrial age and America ruled the digital age, China is positioning itself to lead the autonomous age. But the story isn't over. America still possesses vast technological talent, world-class universities, and unmatched creativity. The question is whether those strengths can transform into coordinated action before China's momentum becomes unstoppable. The world stands at a crossroads, watching two giants shape the future. And in this high-stakes competition, one truth becomes undeniable: the nation that leads in AI, robotics, and advanced manufacturing will define the direction of the 21st century.